Unit 10, Lesson 2. This is Michigan versus Michigan State. We are going to discuss a two-proportion z-test today. There's two methods, the state plan do, conclude, which includes phantoms, and we'll discuss what the acronym phantoms is in just a moment. Okay, so for this particular problem, we have two proportions of two different populations. And one of the populations is Michigan, and the other population is Michigan State. And we are trying to see which proportion of graduates get a higher proportion of jobs. So this particular one has a random sample of 500 Michigan graduates, and 455 got jobs, and that's where this number comes from right here. And then we have the next one is 400 was my sample, and 348 got jobs, and that was Michigan State, and that's where this came from. So we can't really see that. There we go. All right. So you can, when you label these, I have this as proportion of Michigan that got jobs with P1 hat. You could, if you wanted, PM hat, and then maybe I'll put S for Michigan State University. You can use a 1 or a 2. It doesn't matter. Michigan could be 1. Michigan State could be 1. It doesn't matter. That's why you're labeling in them and letting me know which one's which. The difference is just P1 hat minus P2 hat, and that's 4% because 91% minus 87%. Okay, so for this here, I just filled in the data, which was what we just read. Okay, now we're going to do our test. So the parameter is P1 minus P2 is the true difference in proportions that got jobs, Michigan minus Michigan State. You'll often see this also. P1 is equal to the true proportion of graduates at Michigan that got jobs. And then you'll see the same thing of P2 is equal to the true proportion of graduates of Michigan State University that got jobs. So you could see it listed separately like this, or you can see it listed together like this. A P1 minus P2 is equal to the true difference of proportions that got jobs. Since that's what I'm studying anyway, that's fine. But I just want to show you that you can do it either way. All right, so the statistic that we're handling today, the statistic that we're doing is going to be P1 hat minus P2 hat, which we already solved above. The significance level, if you're not given a significance level, we use 0.05 as a default value. It does tell us this value up here, so that's why we're using 5%, but if it doesn't, go ahead and use 5%. Evidence, well, it does ask us, is there evidence that Michigan gets jobs more in a higher proportion? So I'm looking, is Michigan greater than, and this is here, remember, Michigan minus Michigan State is that 4%. And so I do have a little bit of evidence right here that in my sample, I found that 4% of Michigan's graduates had a higher percentage than Michigan State. So I do have a little bit of evidence. So that's what the evidence comes from. Okay, but that's just in one sample. My question is this sample considered to be in my curve on a normal basis, or is it really unusual and not even on my curve? And if it's not on my curve and it's very unusual, then I have reason to question my claim, and then I'm going to reject it. So let's see. Well, this is my claim that this means there's no difference. There's no difference in proportions of Michigan versus Michigan State jobs. This one here says, yes, there is a difference. In fact, this one, P1, which is Michigan, has a greater proportion of jobs than Michigan State. That's what that's saying. So now we're going to go ahead and test our proportion here. And this is a two-sample z-test for proportion. You'll also see it called a two-prop z-test. You can call it. That's what you'll see. That's what I like to call it. That's what your calculator calls it. So you'll see me calling it a two-prop z-test. Prop means proportion. Okay, so we always have to check our two conditions. Our two conditions are random sample and large count. So let's see for random sample. You need to check it for both. And I have 500 Michigan and 400 Michigan State. So you have to check for both of them. And indeed, it was given to us. All right. The large counts, remember, is going to be NP and N1 minus P for both of them greater than 10. Well, all NP is those that are successful. So success means got a job, and those that are unsuccessful, meaning those that didn't get a job. Well, isn't that what this is here? So I've already kind of done this. If we do NP, we can. We're going to get the same thing. Remember, that's my P. And so what we would do is, okay, 91% times 500. Oh, what do we get? 455. So we get the same thing. So anyway, we are just listing all these counts and saying, oh, look, all of my successes and failures from both Michigan and Michigan State are at least 10. So you can just do it that way. Okay, so let's go ahead and bring in, I'm going to make sure that you see where the phantoms comes in, right? P stands for parameter for phantoms. And the parameter right here, we already did. That's what the P stands for. H stands for the hypothesis. A stands for the assumptions and then conditions. Assumptions and conditions. N stands for name the procedure. T stands for the test statistic, and that's what we're doing right now, is the test statistic. Now, to get the test statistic, you see this is just listed here. We're going to actually go to our calculator, and we're going to go to Menu, Stats, Test, and we're going to do a 2-prop z-test. Okay, so I'm going to go ahead and bring us to our calculator. Open up a calculator page. And you're going to go to Menu, Stats, Test, and a 2-prop z-test. It gives you all of this here, successes. That's these numbers here. Successes has to be a whole number, because if I say how many times did you succeed at something, you're not going to say point something. So I have 455 out of 500 and 348 out of 400. So 455 goes here out of 500 and 348 out of 400. The alternative hypothesis is my HA, and remember my HA was a greater than. Remember that was right here. And the way I knew the HA was greater than is, again, because of the question here. It says higher. I'm asking if Michigan is higher than. So, okay, so this is all my data, and you see that the Z is 1.92. My p-value is 0.027. P1 had, there's that 91%, P2 had 87%. That's exactly what I got in my data here. All right. So so let's keep going on our phantoms. P-H-A-N-T. T was my test statistic. O is obtain the p-value, which we also got from the calculator. And M is make a decision. Now the decision we're going to make, the decision is going to be about HO. Before we make a decision, let's go ahead and draw it. You can see that I drew it. I've got a normal model. The mean is 0 and the standard deviation is 1. And I have here, and I'm shading to the right because the HA says greater than. It's greater than this area. So I'm making a decision for my HO. Remember, my p-value is less than 0.05. And so P is low. We're going to reject the HO. And then we're going to conclude. We're going to make a conclusion, make a decision, and we're going to state our conclusion for HA. That's what the S is, state conclusion. And you're going to say, yes, you only can go with HO or HA. So if I reject HO, because P is low, I'm going to go with HA. And I'm going to reject HO, and HO said that there is no difference in the job market. But we rejected and said, yes, there is a difference. In fact, Michigan graduates get jobs at a higher rate than Michigan State. Okay, so your hypothesis, your HO for this one is always either P1 minus P2 equals 0 or P1 equals P2. That means the same thing. Because let's say that this is 0.5 minus 0.5. Well, that's 0. Or 0.5 equals 0.5. Either way, right? Okay, and you can see that for alternative hypothesis, these are your choices. You're either going to be less than, greater than, or not equal to. The calculator you're going to use, again, is Menu, Stats, Test, and this is a 2-prop z-test. And you filled in your X1, N1, X2, N2, and then the alternative hypothesis, which was either less than, greater than, or not equal to. Your state plan do, your parameter, you have for phantoms, P was parameter, and you did H was my hypothesis. A we had with my assumptions and conditions. N we had named the procedure. T we did our test statistic. O we obtained our p-value. And M we made a decision as far as HO. And we have our conclusion, state our conclusion and context, state conclusion and context for HA. All right, let's go ahead and look this. This is taking aspirin prevent heart attacks. So for this one, we have, let's kind of read through it and just see what's important. It has, this is the total number of people in my study, but it says half of them about, you know, that wasn't perfectly in half, but this here, it's saying, this is my control group, or of these took aspirin every other day, and the remaining took placebo, okay? And it has no active ingredient. It says this of the control group, so that's going to be 239 over 11,034, because it says these here were the ones that were the control group. And then that's either, you can call it P1 hat or P2 hat. It doesn't matter, or P control hat. And then P2 hat was going to be the other numbers, which is the 139 over the 11,037. Okay, so then this says, does it provide convincing evidence? When it says that, that tells me to do a hypothesis test. So I'm going to state, you can see here where I kind of talked about before, that you could actually state what P1 is and what P2 is. Or you could state, you could do P1 minus P2 equals the true difference of proportions and of healthy male physicians who take placebo minus aspirin, right? So it doesn't matter. You could do the way I have it typed or the way I just kind of scribbled it right here. All right, my HO is always the same, where it's just P1 is equal to P2. We're assuming that there's no difference. My HA, the reason it's less than is because it asks you, it says right in here, does the study provide convincing evidence that aspirin helps prevent heart attacks? And it means reduces. And so I'm just saying, is it going to be that this one, my aspirin, is less than my placebo, the heart attacks? So, which I have it, I put aspirin, I put placebo minus aspirin, but the aspirin is actually the first, this one here. I think I flipped mine because I have P1. There we go. Because this one here, I have P1 minus P2. I have the 139 first. And that one there is the aspirin. So I should have done aspirin minus placebo. It's important to get them in the right order. It doesn't matter if I did placebo minus aspirin. It doesn't matter if I do aspirin minus placebo. What I'm noticing is that in my work, I did aspirin minus placebo, but then when I stated it backwards. You just have to make sure it's labeled correctly. Okay, so my first, again, P is for phantoms is my parameters, which I did here. H was my hypotheses, which I did here. My assumptions and conditions, it's the random. I have to do random and large counts. I have 4 large counts. P, that's A, name it. It's a 2-sample z-test for P1 minus P2 or a 2-prop z-test. I told you that's also appropriate. And then do the test statistic. To do the test statistic, you'll go to your calculator, menu, stats, test, 2-prop z-test. And on it, you're going to put X1 is going to equal 139. N1 is going to equal 11037. X2 is going to equal 239, and N2 is going to equal 11034. And you're going to notice the HA, and we have a less than for HA. And in it, and out pops the Z. You'll see your Z at negative 5.19, and your p-value is really, really close to 0. It's like point times 10 to the negative. You'll see it with an E like this, and negative, and like 19 or something like that. Like if it does this, this is literally 19 zeros and then 134. So it's super, super tiny. I'm not saying this is what you got. I'm saying this is what something on your calculator would look like. Okay, because p-value is about 0, we have convincing evidence. So we're having PHA. So let's kind of make sure we're good here. PHA and TO obtain the p-value, which we did. And now we're making the decision as far as HO. Remember, P low, reject HO. And this is low, so we're rejecting HO. And then we're going to, since we reject HO, we're going to go ahead and state HA. We're going to go ahead and say we have convincing evidence to do HA. We don't ever accept it. We don't ever say we prove it, because that's just a little bit too strong to say. It's just saying that we have evidence to go ahead and proceed with HA, and then we go from there. All right, this says if I made an error, which one would it be? Well, since I rejected, it would, if I made an error, went back and go, oh no, I made an error, that would be a type 1 error. A type 1 error is an error that rejects it when I should have not rejected it. So if the aspirin really doesn't help, we will have made a type 1 error because we found convincing evidence that it does help, but it actually doesn't. We cannot generalize results because we did volunteers, and to generalize results, we need a random sample. Okay, we had a randomized experiment, which was great, and we're able to draw cause and effect conclusion, but I can't do a random, or I can't generalize it unless I have a random sample. Okay, I hope this helped. Thank you so much.